the user was to enter a negative number, we wouldn't add the sum and we wouldn't increment. And on the next, when we check this expression on the next iteration, it would evaluate false, and we would exit the while loop. Once we exit the while loop, we need to check to make sure that the count is positive, because if the count is 0, we have to divide by 0 error. And so if it's positive, then we can print out the average. And since all of these were ints, we need to cast up to a double so that we can properly calculate our average. So we cast our sum, and we divide by the count. Right? It's a simple average. If count was equal to 0, we need to print out some sort of error statement. In this case, the person was pretty negative, they didn't enter any positive values, so we exited right. Okay, so here you can see how we can do averages, but keep in mind that we have to do this artificial initialization to kick off the while loop. It turns out we can avoid that by using something called a do while loop. And a do while takes the following format. Do the following statements while this expression is true. So here, first the statement is executed, then the expression is evaluated. So with the do while loop, we're always going to run through these statements at least once, right? But we might iterate, right? We might loop, and that's based on the value of the expression. So if the expression is true, then we'll repeat until that expression becomes false. And then once that expression is false, we continue on with our program. And looking at our flowchart representation, again, we hit the do while loop in our program. The statements get executed. Then we check the expression. If the expression is true or not equal to 0, then we repeat our statements. If the expression is false, we continue on with our program. And so you can see with the do while loop, we're always going to run through these statements at least once. So in our previous example, we could have written the loop a little differently. We could have asked the user, we could have used the do to make sure that we asked the user for a positive integer at least once. Right? And again, the big difference here is we will definitely execute these statements at least once. So going back to our average program, let's calculate average using the do while. So here is all of the code, and we'll go through it line by line. Notice we don't need to initialize the value of next, we just need to declare it in this program, because what we're doing is we're prompting the user here, and then we can check the user's value, and finally decide if we should iterate based on the value of the user input. Right? So here the user is definitely prompted at least once, and the code is a bit more concise. Again, the key is here we didn't have to do our artificial initialization. So clearly while and do while are very similar. So when should we use while and when should we use do while? Well, generally speaking, if the iteration is always going to be performed at least once, we want to use a do while, right? Because we want to run through those statements. If even the first iteration might depend on the condition, then we'd use a while. And now keep in mind, these are general rules. There's always going to be exceptions, and we could use a while statement if we used artificial initial conditions. And there might be cases where you're writing code where it makes sense to do this artificial initial condition, or the initial condition might be decided upon by an earlier user input. Okay, so that's while and do while loops. Is that fairly clear?
I have a question about the average program. So since next is greater than 0, like any function of the positive integer, will that ever end?
So if you keep entering positive integers, the program will just keep continuing. Yeah. So it's I wouldn't call this an infinite loop because the loop is dependent the user can always enter something that will cause the loop to exit. Okay, so for loops take on the following format. So the keyword for, a set of parentheses, and within the parentheses there are three expressions. And each of these expressions has a special meaning that we'll get into. And then there are obviously our statements that we want to iterate. So first, expression 1 is executed, and that initializes the loop. So it should be values that initialize the loop. Next, expression 2 is evaluated. And if expression 2 is true or non-zero, then we'll execute the statement. After executing the statement, we'll execute expression 3, and we'll keep doing this order of execution as long as expression 2 is true. As soon as expression true evaluates the false, the program will proceed with the next set of statements. So let's look at that with our flowchart representation. So we hit our for loop. Expression 1 is evaluated, which initializes this for loop. Expression 2 is evaluated. If expression 2 is false or equal to 0, we would just continue on with our program. However, if expression 2 is true, then we execute our statements, then expression 3, and then we check expression 2 again. So it turns out that each of these three expressions can be empty, and C will actually interpret the empty expression 2 as true. So if you left expression 2 empty, you would have an infinite loop scenario. So let's look at some examples. So let's say we wanted to take a sum of the first n integers. Here's an example of a for loop that would do this. So we initialize sum equal to 0, and then we go into our for loop. So the first expression, as I mentioned, is used to initialize the loop. And here we usually put variables that are going to be important for deciding whether we iterate. And the variable that we're going to use is I. Right? And so we initialize I equal to 1. And then we would check expression 2 to see if it's true or false. If I is less than or equal to n, then we should execute these statements. Here, execute the statement. So here we just add the value of I to sum. After running that piece of code, we execute expression 3, which is just an increment. So I gets incremented. After I gets incremented, we check expression 2 again. And we keep running this loop as long as I is less than n. As you hopefully see, that would be the sum of n integers.
So expression 1 initializes, and expression 2 is the one that comes after. So at expression 3, it doesn't go back to expression 1, it goes to expression 2, right?
Yeah, so that's important. Expression 1 is only run once. It's run before you enter into a potential scenario. So let's look at another example where we're taking the product of the first n integers. So here we are calculating the product, which will get set to factorial, this variable factorial. We initialize factorial to 1, and then we loop from 2 to n. Right? We don't need to start at 1 because if we started at 1, we'd just be multiplying by 1 to get an identity. So that's inefficient. So we can just initialize I to 2 and keep running this operation till I is greater than n. So what's the value of I after the loop? Any guesses? So we're going to keep looping as long as I is less than or equal to n. And on each loop, we're going to be incrementing I. So when you look at this, you should see that we're going to exit when n is greater, when I is greater than n. So that's going to happen when n is when I is equal to n plus 1. So it turns out that for and while loops are equivalent. They're equally expressive. Right? You can do the same things with them. Why would you use a for loop? Well, the format of a for loop clearly parses out initialization, the expression that you're checking for each iteration, and your incremental expression. Right? And so that can be very handy. But you can always take a for loop and turn it into a while loop as such. Right? The initialization would happen before the while loop. Right? So expression 1 gets pushed before it. Obviously, expression 2 is what we're checking to see if we're going to iterate. Then the statements would follow, and expression 3, where the for loop always happens right after the statements. So we'll continue next time. We have a few more examples.